used to think that, with my remaining 3 brain cells, I could only afford to cry in order to pass the physics class. But that was before I discovered Hernal's Angels. With these 5-member self-proclaimed girl group, you will slowly understand how even simple organisms could portray and teach you the intricacies of physics. With just your attention alone, these angels will be your guardians to reach the gates of, yes, Congratulations. Ano nasusunod kong gagawin sa buhay kayo. For a limited time offer, watch their lesson about vectors, and you'll get a limited free clip of them painstakingly building a force table.
Will you continue? Yes or no?
First, let's have vectors, equilibrant, and resultant. A vector quantity yields both magnitude and direction. In our force table, the mass of the weights represented by the magnitude using the equation of force is equals to mass times the acceleration due to gravity, which is 9.8 meter per second squared, while the direction is based on which degree in the force table will help retain the center ring given the force probe in different angles. From our force table, the data and observations were based on the vectors with probing forces. These vectors are represented by points, whereas point A has 10 grams or 0.01 kilogram, 0.098 Newton, and 60 degrees north of west. Point B has 10 grams or 0.01 kilogram, 0.098 Newton, and 180 degrees west. Resultant is simply the combination of 2 or more vectors. The sum of these vectors is yielded in representing the vectors of the applied forces acting upon the table. In our force table, both graphical and analytical methods were utilized in getting the resultant of all vectors.
The parallelogram method will be used for the graphical analysis. So what is parallelogram method? When the vectors to be added form the 2 adjacent sides of a parallelogram, by joining the tails of the 2 vectors, and if the adjacent sides of a parallelogram drawn from a point can consider 2 vectors acting simultaneously at a point in magnitude and direction. The parallelogram method is used to add them. So the diagonal of the parallelogram then gives the sum of the 2 vectors.
First, we need to plot the F1, which is the point A, following its measurement of 0.098 newtons, 60 degrees north of west. To plot the Newton in our graph, we set the preferred equivalent, which is a 0.0245 per 1 inch, while the angle degree will be based on the protractor. Once the F1 is plotted, F2, which is the point B, will be plotted with the measurement of 0.098 newtons, 180 degrees west. To be able to execute the method, we will be copying the point A and point B on the opposite side to complete the parallelogram and get the resultant.
After plotting the F1 and F2, it is time to get the resultant by measuring the starting point and the end point of our vectors. With this, our resultant is 0.0931, 60 degrees north of west.
In using the analytical method, we first got the x and y components of each point. For point A, we used cosine 60 multiplied to 0.098 newtons for the x component and sine 60 multiplied by 0.098 for the y component, having a result of 0.049 and 0.085. It was much easier for point B with an x component of negative 0.098 and y component of 0. With this data, we were able to use the formula square root of x squared plus y squared to get the resultant, which is 0.098. We used the tangent is equals to sum of y components over sum of x components for the angle, getting 60.04 or 60 degrees. Equilibriant is a necessary component in making sure that the weights in a force table remain in their fixed positions. Equilibriant is noted as equal in magnitude but opposite in direction to the resultant force. In our force table, the equilibriant, which is point C, weighs 10 grams, 0.098 newtons at 295 degrees. This will be the magnitude and direction of the third force so that the center ring will remain in its place.
Hi! Welcome sa 5 minutes class ng Hernal's Angels. Yung materials na ginamit namin ay karton para sa pang-support sa column at yung platform na mismo, tapos styro din. And then para sa column, balloon sticks siya na pinagdidikit-dikit. For the pulleys naman, gamit namin clips. Then cross-stitching yarn for the strings. For the pin naman, gamit namin yung sticks na kinuha from the group nila Anika. Salamat. Of course, yung rings and then yung weights na mukhang yema, pero sand lang talaga yan. At yung theme namin is Constellation or Galaxy, kaya black paper. To sum it all up, hands down sa nag-invento ng force table in this activity, we realized the importance of this tool because it helps us to visualize the vectors much easier. Despite its subjectivity to errors, accuracy of the results were utilized from the knowledge of trigonometric functions o yung sa katawa, yun lang. So ayun, finished product! Yay!
This video is brought to you by Hernal's Angels. Starring Ms. Andrea Esguerra,
Grabe, physics na naman. What if umiyak ako?
Ms. Diane Rubio,
Hay naku physics, tama ka na.
Ms. Honey Guzman,
Nahihirapan ka rin ba sa physics? Ox lang yan, keep naman tayo.
Ms. Ryan Magbago,
Ano ba naman yan? Ang daming gagawin?
Ms. Jen Dumlao,
Ayoko na, pagod na ako.
Mahalagang paalala, ang palabas na ito ay hindi gamot at hindi dapat gamitin gamot sa anumang uri ng sakit, hatid ng pagbagsak sa physics. If symptoms persist, consult Ms. Mary Joyce Ocampo Hernal.